Hi, welcome back to my YouTube channel. In this video, we're going to look at how to solve more problems on differentiation of functions. And the first one will be how to find the gradient of the tangent line to a curve at a particular point, right? And then other questions on derivatives. So let's just get started on the first one. Okay, so we are given a function z and w is a function of z, okay? All right, and we're trying to find the gradient of the tangent line to the curve at a particular point. Now, what does this mean? Basically, what it means is we should find the derivative of this function with respect to z and evaluate it at the point z equal to 3. That's all. I mean, that's everything that we need to know about how to solve this problem. Now, but why is this the case though? Why does the gradient of the tangent line mean this? Okay, so just think about, so let me give you something that is easy to see. So let's say we have this function, which is actually y equal to x squared. Let's say we have this function. Now, if I want to find the gradient of the tangent line, now at this point, let's call this x naught, right? And then this is the tangent line at that point, okay? Now, the gradient of this tangent, which is the slope of this line, okay? Because this line has the same slope everywhere. It has, at any point on this line, so all of these points, the slope is the same at each of these points. So it will also be the same here, right? So that's why for me to find the slope of this line will be equivalent for me to find the slope at this point, the slope at that point. Now, what is the slope at this point? It's just basically when we find the derivative of the function and evaluate it at that point x0. So this is why the slope of the tangent line is equal to the derivative of this function at this evaluated at this point x0, which is exactly what we are going to do here. So the first thing is we need to find the w dz. Okay, so we can see that this is quotient of two functions. So we are going to use quotient rule for this differentiation. So basically we let z, the numerator to be u and the denominator to be v. So now to find the w dz, it will basically be what? Remember the quotient rule, it says v times du minus u times dv. So all over v squared. Now, so we just have to make sure that we're consistent with the notation, because in this case, this is not with respect to x, it's with respect to z. So it's going to be du dz minus u dv dz all over v squared. So this one we need to apply to get our derivative. Now, we know that what our u is z cubed, our v is what? Z squared plus 1. So find du dz, which is very easy, which is just 3z squared. Now find dv dz, also very easy, which gives us 2z. Now, because we know this, we can quickly apply this into this equation, right? So we have v z squared plus 1 times du. What is du? 3z squared minus u, which is z cubed, times dv, which is 2z, all over v squared, which is z squared plus 1 all squared. Okay, so all you need to do is to simplify this. So like I said, you just need to multiply. So I like to replace the order, so to switch the order for easy identification of how to expand this. So we can just quickly say this is 3z squared multiplied by z squared plus 1 minus z cubed multiplied by what? 2z all over z squared plus 1 all squared. Now, when you multiply this, the first one will be 3z squared multiplied by z squared. That will be 3z raised to power 4 plus 3z squared. This multiplied by this is 3z squared. Then minus 2z raised to power 4, which is z cubed multiplied by 2z, and then all over z squared plus 1 all squared. Okay. So let's quickly simplify and finish this. Now, 3z raised to power 4 minus 2z raised to power 4, that will give us z raised to power 4, plus we still have 3z squared here. all over z square plus 1 all square. Now, this is the w dz. Fine. Now, we are asked to evaluate this at where? At z equal to 3. So what does that give us? That would imply that what 3 raised to power 4 plus 3 times 3 square all over 3 square plus 1 all square. So what is 3 raised to power 4? So that is 81 plus 3 raised to power 3, that is 27 all over 10 square. So this is basically 108 over 100, right? So you can simplify as 54 over 50, simplify further as, 2 can go again into 54, that is 20, is that 27? Yes, I think that's 27 over 25. So this would be your final answer to the problem. Okay, so that is the first of the 3 problems that we need to solve. Let's move to the second one. So the second one is asking us to find the derivative of e raised to power minus x squared sine x squared. Okay, so let's look at the second one. Our function is this, e raised to power minus x squared sine x squared. Okay, so how do we approach this problem? Now, remember, we have to use one of the techniques of differentiation for this particular problem. Now, how do we know which rule we are supposed to use? What will give it away is when you substitute a variable for your functions. That would make it very clear. And how you recite the function will also tell you, will also give you an information about what rule you're supposed to use. Now look at this function. We call it e raised to power x squared. E raised to power minus x squared multiplied by sine x squared. So this tells us there's a product rule in this particular problem. So all we need to do is substitute a variable for the first function and another variable for the second function. So we let u to be e raised to power minus x squared, and we let v to be sine x squared. Now we know that what y would be u times v. So it tells us that what is going to be product rule. And what is the product rule? Don't forget dy dx says u times dv dx plus v times du dx. Now, what we need to find now is dv dx and du dx. So we have u as this. What is du dx? Okay. Now, when you look at u, right? U is a nested function, right? So we have 2 functions nested together as one. The first one is the exponential, and the second, which is e, and the second one is minus x squared. Right now, when you have this, you should know that you have chain rule. Now label them. The external function is the outside one, which is e, and the inside function becomes the internal part of the function, which is minus x squared. So all you need to do in chain rule is to multiply the derivative of the external function by the derivative of the internal function. Now, if this was a standalone problem, you would have to show all the steps by substituting another variable for minus x squared. But in this particular case, because this particular function is in between, is inside a bigger problem, you don't have to go through those steps. You can quickly write your answer in one step, right? Which is what I'm explaining right now. So what you need to do is you multiply the derivative of the external function by the derivative of the inside function. I have also explained this in the previous videos. If you haven't watched those, please go into the playlist. The link is down below, and make sure you watch those videos as well to understand how chain rule works. Okay, now how do we find du dx? Derivative of the external function, which is derivative of e, and derivative of e is the same thing as e of whatever is inside that e, which is minus x squared. So this is the derivative of the external. We multiply this by the derivative of the internal, which is derivative of minus x squared, which is just minus 2x. So the answer to this is minus 2x e raised to power minus x squared. Now, what about dv dx? We use the same thing. Sine is the external function and x squared is the internal. So find the derivative of the external multiplied by the derivative of the internal. Now, derivative of sine is just cosine. Cosine of what? Whatever is inside that sine, which is x squared, multiplied by derivative of x squared, which is 2x. Okay, so the answer to this is 2x cos x squared. Now that I have this, I can just quickly substitute this into the function that I have, which is derivative of y with respect to x, and then finish the problem that way. Now let's just write this. U is e raised to the power minus x squared times dv dx, which is 2x cosine x squared, plus v, which is sine x squared, multiplied by du dx, which is minus 2x e raised to the power minus x squared. So this is all you need. Just simplify this and you're good to go. Observe that what you can write this as minus x squared. Then the other one is minus 2x e raised to the power minus x squared sine x squared. And then we can see that what 2x e raised to the power minus x squared is common. So just bring it out. You don't have to do this, but it's quite nice if you can factorize to make your answer look very crispy, okay, and compact. All right, so this would be the answer to the problem. Now, the last part, obtain the derivative of 3x sine x times cosine x. So let's do that. So the third part is, if the function is 3x sine x times cosine x, find the derivative of this. This is quite easy as well. As you can see, you have product rule in this case. You have product of three functions. The first one is 3x, second one is this, and third one is this. Now, you can also look at it as a product of two functions, where the first one is 3x sine x, and the second one is cos x. So you can do that substitution. Make u 3x sine x, and make v cosine x. Okay. You could also look at it as what? Let u be 3x and let v be sine x cos x. Whichever way you look at it, your answer will still be the same. Your answer will still be correct. Okay, but I'm looking at it this way. All right. Now, what is dy dx again? Exactly the same thing. Your guess is as good as mine, which is u dv dx plus v du dx. Now, what is du dx? So du dx is derivative of 3x sine x. Now notice again that we have product rule guiding this, because we have product of two functions. One is 3x, the first one is 3x. This is the first one, and the second one is what? Sine x. So which means we use product rule. And what is that? We leave the first function, which is 3x, multiplied by the derivative of the second function. So I will do it in one more, which is this prime means derivative of the second function plus the second function multiplied by the derivative of the first function. So what do we have? 3x times derivative of sine x is cos x, plus sine x, derivative of 3x is 3. So this will give us 3x cos x plus 3 sine x. So that is du dx. What about dv dx, which is the second one? dv dx is just derivative of cosine x, which is what? Minus sine x. Now we are good to go in terms of finding dy dx. Now, which is u dv dx plus v du dx. So what is u? Don't forget your u. Your u is 3x sine x multiplied by dv dx, which is minus sine x, plus v. What is v? Cos x multiplied by du dx. What is du dx? We got it as what? 3x cos x plus 3 sine x. All right. So this gives us minus 3x sine square x. If you simplify the first term, then when we expand this, we have 3x cos square x, then plus 3 sine x cosine x. So so you can leave your answer as this, or if you like, you can simplify further by factorizing 3 out. So you have cos square x minus x sine square x plus sine x cos x. Okay, so what I just basically did is I took 3 out. I wrote this function first. What is remaining, which is oh, sorry, I missed an x here. So I have x cos square x, then minus, write this one, which is x sine square x. Then finally write the remaining part of this third one, which is sine x cos x. And that's the end of this particular problem. So if you do enjoy this video, this type of videos, please give me a thumbs up and the like, click the like button, and then share this on the social media channels, as well as, tell your friend, anyone you think would need to learn from these videos. Do share these videos with them. And then if you haven't subscribed to the channel, make sure you do subscribe to the channel to allow the channel to grow so that it can reach more audience, can reach more students like you that will benefit from this channel. And that will be the end of this particular video. I will see you guys soon in the next one.